A customer submits a refund dispute at 11:47 at night. By 11:48, it is answered and cited. The human owning the financial liability is fast asleep, leaving a critical window where an autonomous system must handle complex policy without human oversight. This diagram maps where Agent 04, the Knowledge Retrieval Agent, sits within the hierarchy. It inherits decision-making from Agent 1 and planning from Agent 2, functioning as the load-bearing primitive for the knowledge tier. Any system performing complex document intelligence scales from this exact architecture. It operates under a single absolute law. The agent is strictly forbidden from answering any prompt using its own internal weights. Instead, it is forced through a strict mechanical loop. It must interpret the query, access an external archive, fetch verified evidence, and only then construct a response grounded exclusively in that data. A bare large language model acts like a brilliant scholar who hasn't opened a new book in 2 years. Agent 04 acts as a researcher required by the system to staple a citation to every claim before it is allowed to speak. We can observe this architecture operating in Manchester, a boutique leather goods business processing over £2 million a year in revenue. A customer in Edinburgh uploads a scanned purchase contract. They are 4 days past the return window and they want their money back. Routing this exact prompt to a standard conversational chatbot creates an immediate risk. Models prioritize conversational fluency and helpfulness over rigid legal boundaries, often apologizing and approving refunds that violate company policy. The actual UK consumer law states that any refund processed 14 days post-delivery is strictly capped at 15. The business owner absorbs an immediate £340 financial loss, and any attempt to reverse the error the next morning results in a public 1-star review. When this ticket hits the AskAI processing pipeline, the system delivers a fully realized reply in exactly 23 seconds. The reply quotes Clause 4B, calculates the correct UK jurisdiction cap, and attaches a hyperlinked copy of the updated policy document. This specific response prioritizes a liability shielding resolution, enforcing strict compliance even when the customer's request sounds reasonable. Standard retrieval augmented generation relies on a serial chain, reading the document, then querying the database, then checking rules. In an enterprise environment handling thousands of live tickets, that sequential queue creates latencies that violate service-level agreements. This schematic visualizes the fork-join architecture solving the latency problem. Instead of a chain, AskAI triggers 3 distinct retrieval arms concurrently. Arm 1, the document analytics agent, runs a hybrid optical character recognition pipeline pulling spatial key value pairs directly off the raw upload. On clean, standardized contracts, it reaches 95% extraction accuracy. When processing noisy, watermarked hand scans, that rate drops to 82%. Arm 2, the compliance verification agent, functions as a stateless safety gate for the entire process. It completely bypasses large language model involvement, relying on pure Boolean algebra to calculate deterministic policy intersections. The underlying mechanism is a shadow MVEL rules engine. It mathematically enforces tenant-scoped legal caps, ensuring limits are applied without the risks of text generation. Simultaneously, Arm 3, the real-time data retrieval agent, queries read replicas of production platforms like Zendesk or Salesforce to extract live thread history and order status. It operates under a strict 5-second timeout budget. If the production database lags, the arm severs the connection and pulls a safe cached snapshot to maintain the processing pipeline. These 3 independent data streams reach the convergence gate. Here, the system deduplicates the facts by source ID and compiles them into a single, tightly bounded context window. Achieving autonomous resolution in under 30 seconds, the generation step only occurs once the facts are secured. At the convergence gate, the compiled data is handed to the LLM with a directive. Across 1 million tickets, the latency mathematics look like this. The system waits for the slowest of the 3 concurrent arms, usually 7, 2, or 5 seconds. Adding 3 seconds for generation and 5 for overhead results in a median processing time of 16 seconds. The Edinburgh request required 23 seconds, because the optical character recognition layer encountered a heavy load while rendering a blurry PDF, that the output remains legally bounded. Advanced retrieval pipelines frequently encounter a specific failure mode, the Ghost Citation. The document arm extracts Clause 5A from the customer's outdated version 3 contract. Meanwhile, the compliance arm evaluates the claim against the active version 2 rulebook, where Clause 5A means something different. When fed contradictory facts, an unprotected language model will often weave them together, generating an authoritative response, citing a rule that does not legally exist. To mitigate version drift, engineers install a semantic clause matching layer. It uses many LM version 2 embeddings and cosine similarity algorithms to cross-check the hashed text between the two sources. If the similarity registers below 0.85, the system aborts the generation. The ticket is immediately pulled from the automated track and flagged for human review. Production AI follows a strict hierarchy. It is safer for an agent to admit ignorance and escalate the ticket than to fluently cite a fabricated legal clause. This chart diagrams the market distribution for AI support platforms, a sector scaling past $35 billion. At the higher end, players like Zendesk and Sierra build integrated enterprise deployments. AskAI targets the SMB tier with a plug-and-play architecture requiring zero developer setup. An external forcing function is equalizing engineering standards across these tiers. The full enactment of the European Union AI Act alters baseline deployment requirements. The regulation mandates that operators disclose AI interactions and maintain the architecture to trace an automated decision directly back to its source data if challenged by a consumer. Implementing a strict provenance pipeline has transitioned from an optional best practice to a legal requirement for operating in the European market. This impact dashboard tracks the viability of parallel triangulation at scale, maintaining deflection rates above 75% across millions of requests. The achievement of Agent 04 is the verifiable, legally binding receipt stapled to the final answer.